Let's complete this packet that we did yesterday about transformations. So we looked at our parent function, which was through the origin. It's symmetrical on the y-axis. There are transformations. Down here, let's write what possible transformations can happen. So one of them is reflection. And then another one is translation. And then we have stretch. So if it's stretched, it's kind of like if you are stretching your arms up in the air and then somebody helps you stretch even further, your arms are going up even closer to your head. So it would be like this. That would be a stretch. And then compression is whenever it gets flatter or fatter, something like that. So it's more like a bowl compared to something real skinny. So we know that if a, the number out front in front of the x squared, is negative, there will be a reflection. If the a, then we look at a without the positive or negative value and just think about it as, let's say it's 3. It's greater than 1. That means it's going to stretch, increase a lot faster. If it's less than 1, so let's say 0.5, 0.75, 0.8, it's going to be a compression. The h goes left or right. And then the k translates the quadratic parabola up or down. So we have this example. It says graph each function. How does the graph of each equation change? So remember when we were graphing using vertex form, we put y equals ax minus h squared plus k. We were at the formula right underneath it. Then we determine what our h and our k and our a is, and we can write those. So the a value is just 1 because there's nothing there, right? So we know it's 1. Okay, what about the h value? This is supposed to be minus h, but it says plus 2. So it must be x minus a negative 2. So h is negative 2. The h is always opposite the sign that it's given. K is the exact sign that it's given. So the k is the negative 3. So if a is positive 1, there is no reflection. And no shape change. So whenever I say change in shape, that means you're either stretching or compressing. In this case, it's 1. It stayed the exact same, so there's no change in the shape. So the h is negative 2, and h tells us left and right. So if h is negative 2, that's going in a negative direction. So it's going to be left 2. And then the k is going to be telling us how it moves up or down. So if it's negative 3, that moves in a negative direction, which means down. Do you remember how we found what the vertex was whenever we were given the vertex form? The vertex is hk. So in this case, it was negative 2, negative 3. We can check this, and we are going to check it by putting it in our calculator. So everybody get out your calculator. We're going to put in the original quadratic function, so y equals x squared. That's our parent function. And then y2 will be the function that we're given, x plus 2 squared minus 3. Hit graph. So it's the exact same shape. Do you see how it's the exact same shape? Same width as the other one. So the blue one is our quadratic parent function. The red one is our new function. It's the same shape, but it was moved left 2, down 3 to our new vertex. So you can follow the vertex by doing the left 2, down 3. Okay, let's look at the next one. Let's identify what our values are. What is A? Negative half. Yep. So what's going to happen to it? Let's look back over here. Let's look at the first thing. If it's negative, it's going to reflect, right? So let's write that. Reflect. And then the half, it's less than 1. So it's going to compress. The h value, x minus h squared plus k. What is the h value? Negative 2, yep. What is that going to do? The h moves it left and right, so which way is it going to go? Left 2. What's the k value? 0. So is it going to go up or down? No, up or down. So let's graph it and let's see what it looks like. So keep y1 as our parent function, x squared. So y2 graph it. And let's see if we did the right thing. So that's our original. Is it a reflection? Yep. Is it compressed? Is it the same shape? It's not the same shape. It's more wide. See how wide it is compared to the other one? And then it did not move up or down. It stayed on the x-axis. Okay, let's look at our EOC review that we've been doing. We're going to look at number 10. The graph of a quadratic parent function f was transformed to create the graph of g of x equals f of x plus 2. Which graph best represents g? So we know the quadratic parent function. That is f of x equals x squared. So x is the variable here for f of x, and it's x squared. For g of x, see how it says f of x plus 2? We need to find out what f of x plus 2 is so that we could input something here. So instead of saying x and x squared, it's going to be x plus 2 squared. So we're doing some substitution there. So now I can rewrite this g of x as this is going to go in the place of the f of x plus 2. So it's x plus 2 squared. And then we need to just keep the minus 5. We can graph this, but we can also know what our h and k are. What is the h? Negative 2. What's the k? Negative 5. So how was it the parabola moved? If it's negative 2, how was it moved? Left 2. And what about the minus 5? Down 5. So look for the one that the parabola was moved from the origin, left 2, down 5. And it's the exact same shape. You can also graph it because we know what the equation is to see what it looks like. Okay, let's go to the next one. Number 11. The graph of f of x equals x squared was transformed to create the graph of g of x equals f of x minus 9. Which statement about the graphs is true? So we know what f of x is, right? It's x squared. So we are going to plug in this x squared for f of x. So instead of writing f of x, I'm going to write x squared. So this is g of x equals x squared, because f of x is x squared, minus 9. And what do we know about the graph of this function? What is the only change that it's going to have? But is that the h? No. The h is the x minus h squared plus k, right? So do we have an h? Do we have an a? We only have a k. And what does the k tell us? Yep, up or down. So if it's negative 9, what's going to happen to it? Down 9. So let's look at our answer choices. The graph of g is a reflection. Is it a reflection? Nope. The vertex of the graph of g is 9 units to the right. Was it moved 9 units to the right? No. The graph of g is a reflection? No. The y-intercept is 9 units below the y-intercept of f. Yep, because it was moved down. Yay. And number 12, the graph of quadratic function p is shown on the grid. If k of x equals x squared and p of x equals k of x plus n, what is the value of n? So see how this says k of x equals x squared? So we are going to input this x squared for k of x. And rewrite it as p of x equals k of x is x squared plus n. So what is the n going to be on this? The k value, yeah. What's the k value? Yep, negative 6. So it went down 6. So x squared minus 6. So when you bubble it in, make sure you do that negative. There. 6 can be anywhere along here. You can put it at the front, you can put it at the back, put it in the middle. As long as you don't put a decimal before it, you're okay. I just go ahead and just do it like that. If you want to, put a decimal in there just to make sure, or you can put it at the end. We could have put it at the end and put that negative and been done with it. Either one is correct. You decide how you want to do it. Okay, so that is it for transformations of quadratic functions.